Good evening, everyone. So welcome to the live session on machine design. So myself, Dharan Sai, the faculty for machine design. So here in the session, we'll be seeing the most important as well as the previous year questions which have appeared in ISRO. These are some basic questions. Generally machine design is considered to be one of the most important and scoring subjects in ISRO. Okay, so at least we can get 10 questions from this particular subject. So because of which, as we can notice that it is having good weightage. Okay, as it has good weightage, the questions from this subject are generally theory based and generally very easy. Okay, so from each and every chapter, we'll try to solve questions and then we'll see the answers for them. Okay, the most important questions itself we are trying to solve here. It is not every question which has appeared in the ISRO examination. Okay, now moving ahead, if you observe carefully, on loading a ductile material, he is speaking about which material? It is regarding ductile material. So in excess of a certain value, so here gradual increase in elongation, which means here the loading is gradual loading, occurs with the time. Whenever gradual elongation is occurring with time, then it is called as creep. Okay, so the answer, the phenomenon here is called as creep. Okay, now if at all if you have any queries in between, you can post your queries or you can post your answers whenever you are seeing the question, immediately you can post your answer, so in the comment section. Okay, so moving to the next question. For thin cylindrical shell structures loaded in compression. Now here the member is loaded in compression. If at all if that is loaded in compression, we need to design for the compressive strength, right? Now here among the four options, what is the compressive strength? That is what we need to check. Now here yield strength of metal, he didn't specify that that is tensile or compressive. Ultimate strength, so considering them to be tensile in nature. Now here buckling strength of the material, see here, so our buckling strength of the structure, this is considered to be the compressive strength. It is not shear strength. Yes, obviously as it is subjected to compressive loading, it has to be designed for compressive strength. Okay, now let's we'll try to solve as many questions as possible. So mostly as it has theory based questions, let's see them. Okay, so the most important chapter here is static loading. From this chapter, majority of the questions pop up, majority of the questions appear, especially from this chapter. Okay, so from the theories of elastic failure, now let's see the answer to this question. The failure occurs at a point in a member when the maximum shear stress so here he is speaking about maximum shear stress, reaches the shear stress at elastic limit in simple tension test. This is according to, we are considering shear stress according to which theory? So what is the answer here? Can you please say me what is the answer for this? Let me see what is the answer. Please give me the answer. Is that A, B, C or D? Yes, you are right, it is Gus theory, which is B. Okay, moving to the next question. Which of the following is applied to brittle materials? Generally for ductile materials we have Gus theory and von Mises theory, whereas for brittle materials we have Rankine's theory, which is nothing but maximum principal stress theory. You should be very fast immediately after seeing the question. So be fast, type your answers in the comment section. Okay, now moving to the next one. So here observe this, I am going out of the screen, just observe this question. Match the following criterion of material failure under biaxial stresses. Now here he is giving sigma 1 and sigma 2 and he is asking us to represent what is the safe region of operation according to various theories. Now here according to maximum shear stress criterion, so here you can notice that the A, according to maximum shear stress criterion, we know that the shape is, so this is what, so what is this shape? Is it a hexagon? Okay. Now here, this is the shape that we are getting according to maximum shear stress. According to maximum distortion, see this is the shape that we are getting. Now which means B goes to L, okay, A goes to N, N, L, M. So maximum normal stress is M, okay. So the answer here is N, L, M, N, L, M, which is nothing but B. Okay, the answer is what here? B. Okay, moving to the next one. The most applicable failure theory for metals like aluminum. what kind of material is aluminium? We know that aluminium is ductile in nature. For ductile materials, we have two theories. One is Tresca, Gestor Tresca theory. Other one is von Mises theory, which is maximum shear stress theory, and distortion energy theory. Among these options, what is given? Shear stress theory is not given, so the answer has to be maximum distortion energy theory. Very simple, isn't it? Okay. Moving to the next one. Oh, this is one of the most important questions. Just read this question. I'm going out of the screen. So just read this question carefully. So here he says that there is a cantilever beam of rectangular cross section. The depth is D and width is B and the length is L. It is subjected to a shear force at its end as shown in the figure. The beam is made of material which follows maximum shear stress. Here, okay, that's fine, that's great. So which of the following statements is or true? Okay. So here, as he is saying, which of the following statement is true? Following is, which means only one answer. Now here, so let's go with the options here. Read the options carefully. The beam section has uniform shear stress. So you can notice that option A, see, as the length is large, if at all if the length is large, so we call it as, so this becomes transverse load. Due to transverse load, the shear stress, maximum shear stress equation is, tau max is what? So is that 3 by 2 times F divided by B into D for rectangular cross section. So it is not F divided by B into D, it is 1.5 times more than the average value. So which means this is wrong. Okay, maximum shear stress in section and maximum bending stress in the beam is equal to, so here he is saying that maximum shear stress, this is the magnitude of maximum shear stress. Now what is the maximum bending stress? Sigma maximum is equal to, we know this equation is 6m divided by BD square. Okay, now here both are equal. Okay, maximum shear stress in the section, maximum bending stress in the beam is equal when L is equal to D by 2. Now here, what is the maximum moment here? We know that it is F into L. Okay, 6 into F, L value he is considering it as D by 2. Okay, which is small d by 2. So divided by B into D. Now if you notice, so BD square, DD cancels out. So this comes out as 3 times F divided by V into D. Now here you can notice that this is greater than tau max. It is not equal to, it is greater than tau max, which means this is also wrong. Okay, option B is also wrong. Option C, for L greater than D by 2, we'll come to that later. So bending stress is developed in the beam is independent of B. Bending stress is dependent on B, right? Which means this is also wrong. Now here you can notice that when L is becoming more than D by 2, we have noticed that already normal stress is becoming dominant. So here, as normal stress is becoming dominant, bending normal stress, okay, we are designing for bending stresses, bending normal stress when length is greater than D by 2. Okay, moving ahead. Okay, steel machine element at the critical section in biaxial stress state with two principal stresses. Oh, so here this is sigma 1, this is sigma 2, sigma 3 is 0. The von Mises stress, we know that von Mises stress is what? Sigma 1 Mises is nothing but equal to sigma 1 square minus sigma 1 sigma 2 plus sigma 2 square. If sigma 1 is equal to sigma 2, we can notice that, okay, so this is also sigma 1 and this is also sigma 1. Now we can notice that sigma 1 square cancels out. 1 Mises becomes equal to sigma 1. What is the magnitude of sigma 1 given? Which is nothing but 300 Newton per mm square. So the answer here is what? The answer here is D. Very simple. Okay. So this is how you need to solve such questions, very fastly. See, even though they are, numerical based, so these questions are generally very easy in nature. Okay. I guess this is very clear. Okay. Moving ahead, good Darshil. Okay, moving ahead. The surface endurance limit of gear material depends on. Okay, so we have entered into fluctuating loading. See, generally endurance strength depends on various parameters. It depends on surface roughness, it depends on size, it depends on the type of loading. Okay, it also depends on the type of material which is used, isn't it? Now here if you notice, so it is dependent on surface hardness. Obviously it depends on surface hardness. Okay, modulus of elasticity, obviously it is dependent. It is also dependent on elastic strength, which means it is dependent on SYT, SUT. Obviously we know that endurance limit is dependent on these values. Okay, now here, so I cannot disregard, I cannot say that only it is dependent on elastic strength or it is only dependent on modulus of elasticity. Obviously, it has to be dependent on all the three. So here I am going with the option D. I cannot say that it is only dependent on elastic strength. I cannot say it is only dependent on modulus of elasticity. So for that reason here, so from the options, I can choose the most probable answer as D. Okay. Now, the main objective of short pinning. So we have seen this in class, short pinning. Now, why do we go with short pinning? Do you remember? So what is the key objective? So when we are going with short pinning. So when we are hitting the surface with balls. Okay, so we are trying to induce residual compression on the surface. By inducing residual compression, what we are trying to do, we are trying to close the cracks. If the cracks are closed, which strength is increased? Whether the life of the member will increase? Yes. Whether the strength of the member or material will increase? Yes. Which means here, by short pinning, we are trying to increase the fatigue strength of the member. Okay, of the material, we are trying to increase the fatigue strength. Good. Okay, see, we are not worrying about surface finish here. No. Okay, so what is the key objective? Here is to induce residual compression by which we are increasing fatigue strength. You need to understand this. Okay, now moving ahead, one more simple question. Now here you can notice that here it is non-ferrous materials. For non-ferrous materials, generally we do not have a specific endurance strength or endurance limit like mild steel. Where in case of mild steel, it is asymptotic at 10 power 6 cycles, right? Okay, so which means it is invariant below 10 power 6 cycles. But here it is not the case. In case of other materials, non-ferrous materials, see, they continuously gradually tend to decrease. The curve goes like this. We do not have any stop to the curve. It still decreases. That's the reason why generally for non-ferrous materials we are considering the criterion for life is 10 power 7 cycles. It is not 10 power 4, it is not 10 power 9, not 10 power 12, it is 10 power 7 cycles. Okay, moving ahead. So this is one more simple question. For a plate with elliptical hole subjected to tensile stress. So here you can notice that from the top we are applying this tensile stress. This is the direction of loading. So here, as shown in the figure, the maximum tensile stress at point P. Okay, so this is the critical point, as we know already. Okay, so as this is the critical point at this location, he is asking us to identify what is the magnitude of stress. Okay, so actually it should not be in terms of sigma. So here he has to represent the nominal stress here. Okay, generally, frankly speaking, so we have the relation between sigma maximum and sigma naught. Okay, sigma maximum is equal to Kf times or Kt times. Okay, considering knot sensitivity to be equal to 1. Okay, Kf times sigma naught. Okay, sigma naught is not the stress at the free end. Okay, so here if he is considering sigma to be the stress at this section, okay, at this minimum cross section, then in that situation, okay, so obviously let's see, so is that okay, let me find the value of Kt here. So Kt here we are writing this as Kt. Why? There is nothing given regarding knot sensitivity, so we are writing it as Kt. This is equal to 1 plus 2 into lateral dimension cut. So lateral dimension, so what is the lateral dimension here? 2 times A. So in this 2 times A, half value is semi value is A divided by longitudinal dimension is B. So please say me, is A greater than B or not? Obviously A is greater than B. From the observation we can notice that A is greater than B here. If A is greater than B, so this value is greater than 2. Second term is greater than 2, which means 1 plus greater than 2 value, which means generally this value has to be, the stress has to be here more than, okay. So even if I consider this value, it has to be more than 3 times sigma, okay. The answer is T, okay. The main objective, again the same question. See, such questions are generally repetitive in nature, kindly understand this, okay. So what is the answer here again? The answer is A, fatigue strength, okay. Now I guess you guys are giving the answers. So make sure that immediately when you see the question, you give me the answer very fast. Okay, so kindly give the answer very fast. Okay, now moving ahead. So if an element is loaded as shown in the figure below, the von Mises stress will be closest to 2. So here it is 3-dimensional loading. So here, we have some deduced form of von Mises stress. Okay, so here when we are considering von Mises stress, so there are various ways of writing these equations. We need to know which equation to be used. Okay, so we can write this as under root half of sigma 1 minus sigma 2 whole square, okay, plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. This half is present, okay, for all these terms. Okay. Now here if I consider, okay, so if I do this simple calculation, here we are getting sigma 1 minus sigma 2, okay. If I consider this as sigma 1, this as sigma 2 and this as sigma 3, and here you can notice that 300 minus 100, or if this is sigma 1 and this is sigma 2, the range here is 400. So here 400 square plus, okay, sigma 2 minus sigma 3. So which is 250 square plus, again the difference between the range between these two, it is 150 square. Okay, so this is half of this value and which is in the root. If you do this calculation, the value of von Mises stress comes out as 350 megapascal. Okay. So the simple calculation will lead to a value of 350 megapascal. Okay, I guess most of you have got this answer. Okay, moving ahead, let's go to the next equation. Okay, read this question carefully. A metal alloy machine element is subjected to fluctuating tensile stress. See, I'll not complicate. I'll try to solve any question in limited steps. That is how you need to solve questions even in these kind of competitive exams. So you should not, take many steps. You should not write the equations and then you should not, substitute the values in that equations. Don't waste your time writing the equations. Okay. Now here, so he gave the variation to be, see here, variation, the stress is varying from 100 to 200. So from 100 to 200, what will be the center value? 150. What is the range here? Range is 100, the amplitude becomes 50. See, mean here is 150, amplitude is 50. Directly by the data itself, we can easily identify that. Okay. The material has the yield and endurance strength of, so here yield is given, endurance strength is given respectively. Factor of safety is asked. Okay, as this is fluctuating loading, now we need to consider fluctuating theories of failures. Okay, as yield is given, we need to consider Soderberg theory. According to Soderberg theory, mean divided by SYT plus amplitude divided by SE is equal to 1 by factor of safety. Now what is mean here? Mean is 150 divided by SYT is 450 plus, okay, now here amplitude is 50 divided by endurance is 200 is equal to 1 by factor of safety. This is 1 by 3, this is 1 by 4. Now here this is 4 plus 3 by 3 fours are 12. This is the value of 1 by n value comes out to be 12 by 7. Okay, the answer here is B. If you are doing these questions very fast, okay, so you will be having a lot of edge completing all the questions given in the examination. For you to solve all the questions, so you should solve these questions very fast. Okay, these are very simple. From machine design, the questions generally comes out to be very, 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 very simple. Okay, moving ahead. Okay, I guess you are getting these answers. Are you guys getting these answers? Kindly respond, kindly react. Okay, now moving ahead. So here he is asking us to identify what is a knot sensitivity. Knot sensitivity is nothing but Q is equal to Kf minus 1 divided by Kt minus 1. So here it is there in which option? Kf minus 1 divided by Kt minus 1, it is there in option B. So it is nothing but B. Okay. So here, let's see some questions on shafts. Idler pulley is used. Why are we using idler pulley? So generally in between we are making use of one more pulley. What is the reason? Okay, for changing the direction of motion of the belt. So generally for changing the, so as this is the concept of here, as he considered belt, which means this is the topic from the belt. Okay, so here if that is belt and pulley arrangement. Okay, in case of pulley arrangement, what happens here? Okay, so if at all if you are using idler pulley, so the driver and the driven, so generally the driver and the driven will be operating in two different directions. Okay, but here by placing idler pulley, yes, both, we can achieve the similar direction of rotation of driver shaft to the driven shaft. Both the shafts will be rotating in the same direction. If this is driving pulley and this is driven pulley, so in between we are making use of idler pulley, so that here what is happening, we are achieving the same direction of rotation to the driven shaft as the driving shaft. Okay, so which means this statement is right. For applying tension, yes, obviously, see if at all if as a belt is used, if at all if this goes in, the belt tension will increase. Yes, that is also true. So for increasing tension, okay. For increasing velocity ratio, yes, this is also true. Okay. Now here, why? Because the contact angle will increase here. Now here, as all the three are correct here, we can notice that the answer is D. Okay. Now moving ahead. So see this question, very simple one. I'll be solving this question with logic, simple logic. Okay. So 1/2 length of, okay, so here he is considering a shaft, so in which half the length, okay, is 50 mm diameter steel rod and which is solid. So in the complete length, half length is solid shaft, solid circular cross section whose diameter is 50 mm, and the remaining is hollow, so which is having a bore diameter of 25 mm. Okay. The rod is subjected to equal and opposite torque at the ends. Yes, obviously. Action and reaction. Action, reaction. That's fine. If the maximum shear stress in the solid portion is tau, okay, if that is tau, the maximum shear stress in the hollow portion is. See, if at all if you are removing the material, now you please say me, so in the other portion, do we get more stress or less stress? Material reduced, area is reduced. If area is reduced, the stress will increase. Now here you can notice that it is having, so 15/16 is less than 1, which means it says that it is decreasing, and it says that it is equal to, this cannot be the answer. And here you can notice that 4/3 and 16/15, among these two one has to be the answer. If you observe the data carefully here, now if at all if I consider, okay, the situation here, we know that tau, is that directly proportional to or inversely proportional to section modulus? Inversely proportional to section modulus. Okay. Now here, if at all if I consider solid to hollow, or as here it is hollow to solid. Okay. So this comes out to be, the ratio comes out to be polar section modulus of hollow divided by solid. See, the outer diameter is same. So here I can notice that this comes out to be 1 minus k power 4. So what is the value of k? K value here is, so 1/2. So 25 and 50, the value is 1/2. This comes out to be 15/16. Obviously, hollow will be equal to 16/15 times the solid. Okay, the answer has to be D. Simple question. So even by logic, we can eliminate this. As if you are aware of the data, then by the process of elimination, you can strike this also, and then you can mark this as your answer. If you are smart enough, you will eliminate this also. Okay, someone will worry, okay, is that 15/16 or 16/15? As area is decreasing, the stress has to increase, which means the ratio, the term which we have has to be greater than 1, it should not be less than 1. So the answer has to be D for sure. So which means, so just by the process of elimination also we can get the answer. Good. Now moving ahead. Okay. Two shafts A and B are made of same material. The radius of the shaft A is half that of shaft B. So radius, diameter of shaft A is half that of shaft B. Okay. So the power transmitted by the shaft is, okay, we know that power is directly proportional to diameter cube. So in such situation, okay, A will be, power transmitted by the shaft A will be dash that of shaft B. Obviously, is that 1/8 times or 8 times, 16 times or twice? What is the answer here? If you observe carefully, so it is power transmitted by A is equal to PA divided by PB is equal to dA by dB whole cube. Okay, dA by dB is 1 by 2. Power transmitted by A is equal to 1 by 8 times power transmitted by B. So the answer here is 1 by 8 times. Very simple. As obviously here, shaft A is having smaller diameter. So half, okay. So I can notice that here from the options, it has to be, A has to be the right choice. Why? Because if that is having lesser dimensions, it can transmit lesser torque. Simple logic. So the by logic also we can choose the answer as A. Okay. Again the similar kind of question. Now you say me what is the answer. Two shafts and A and B are made of same material. Diameter of shaft B is twice that of shaft A. The ratio of power which can be transmitted by shaft A to that of shaft B is. So what is the answer here? Now again, as he says twice here, okay, then the answer has to be C. Okay, simple. These are some standard questions that will be asked in examination. So be prepared to mark these standard questions. Okay. Now again the same question. If you see, so the answer here is 1 by 8. Okay. Now moving ahead, let's see. Good. I want you to give responses, quick responses immediately after seeing. So kindly share your responses. Okay. So I want you to, when you immediately see the question, don't wait for my answer. You immediately give your answers in the chat. Okay. Now moving ahead, let's see this question. Very simple one. Now, if such numerical questions are asked in examination, how to solve? Okay. A 3 mm long steel shaft has to transmit 7.5 kilowatt at 3600 rpm. So required shaft diameter is given by. So here he is asking us to identify what is the shaft diameter. Now let's see how to solve this. See here, the torque transmitted has to be generally lesser than its twisting strength, which is SYS. Here SYS value is given, allowable shear stress is given into polar section modulus. Okay. So what is torque here? So torque equation here is 60 into power is given as 7.5 kilo is 10 power 3, 60 P by 2 pi n, 2 into pi into n value is how much? 3600. Now here the unit for this torque is Newton meter. We need to convert this to Newton mm into 10 power 3. We are converting. Is lesser than or equal to SYS value is given as 100 into pi by 16 d cube. Let me do some smart calculations here. So here there is pi and here there is pi. So pi into pi becomes pi square. Now here pi square value is already given as 10. 10 into 100, I am trying to cancel. See pi 100 and this pi and 110 power 3. Okay, simple. Okay, I have simply cancelled. Now here 4 4s are 16. So here 4 how many times? 4 9s are 0 0. Okay. Now here anywhere other. Okay. So here you can notice that. So it is 32s are 30. Okay. Anywhere else the calculation goes here. Now here 7.5 into 4. How much is that? That is 30. 7.5 into 4 is 30. Okay. Now here there is 2 and 2. This also cancels out. Now here d cube is 10 cube. If d cube is 10 cube, d value is 10. The answer here is what? The answer here is, so here it is a simple calculation. Such simple, very simple calculations will be given. See, you should be very smart enough to tackle, to cut down the terms and then to get the answer. Okay. Now here the answer is 10 mm. Okay. A solid shaft can resist a bending moment of, see, are you, please say me, please comment in the chat box whether you are as smart like this to solve, the calculations. Are you really smart enough? If at all, if you are really smart enough in doing such simple calculation, simply type me in the chat box. I wanted to know how many of you can solve questions, as simple as these calculations. Okay, please type me in the chat box. Let me see. Let everyone know. So whether you are capable or not. Let everyone know. So how much you are capable of. Let's see that. That's really great. Good. Okay, that's a great response. So please, if at all if you are not smart to calculate this way, so try to get this, try to improve your skills to calculate this way. Okay, now moving ahead. So don't go to calculator all the time. It is not necessary. Majority of the situations, I am not saying this particular exam. So in any exam, so majority of the times you will be able to calculate by your own mind calculator. Okay, now, so here you can notice the solid shaft can resist bending moment of 6 kilonewton meter and torque of 8 kilonewton meter. So this is multiple of, see, this is 2 times 3 and this is 2 times 4. Okay. Now here we can notice that the twisting moment, the maximum torque that the shaft can resist is. So T is nothing but equal to under root m square plus T square. Okay. Now here we can notice that it is, so under root 6 square plus 8 square. Okay. So these two are, this is 3 square plus 4 square. Under root 3 square plus 4 square is what, taking 2 as common, 2 goes outside. Now we can say that 2 into under root 3 square plus 4 square, that is 5. 2 5s are simple. This is just 10. Yes, the answer here comes out to be 10. Very smart calculations. Okay, let's see this. Which one of the following is not a frictional clutch? Generally from clutches, minimum questions were asked. Okay, even in the past, if you see, very few questions were asked from clutches. Okay, anyway, it is a simple topic, not a big, not a difficult one, by the way. So which one of the following is not a frictional clutch? Okay, so here we can notice that, so single plate clutch, so plate or disc clutch, this is a frictional clutch, cone clutch is a frictional clutch, centrifugal clutch is also a frictional clutch, and jaw clutch, this is a positive clutch. So the answer has to be D. This is most important question from clutches. So remember that from the classification that we have seen in the class. Okay, this question will be asked in majority of the competitive exams. So here, be prepared to mark the answer and leave. Okay, now moving ahead. Again, one more simple question. Read this question carefully and I'll give you the answer. First, observe this. So those who have attended my sessions, you will be much aware of the procedure to solve these questions. Okay, let me give you the simple procedure to solve this. So we don't require complicated procedure, even though the question seems to be little lengthy. So the answer is not that lengthy, and most of you know how simple the answers are if you have attended my sessions. Okay. The block brake with 400 mm diameter is used to brake. Okay, so here the braking torque is 100 Newton meter as shown in the figure. If the coefficient of friction is given as 0.25 at the brake surface, so what is the value of F to be applied at the end of the lever? So here this is what is the question. So here he is asking us to identify how much load can be applied to achieve a braking torque of 100 Newton meter. That is what is the question. Simple, direct, straightforward question. We need to identify what kind of brake is this. Is this self-energizing or non-self-energizing? So here, if you observe carefully, the direction of rotation is given as counterclockwise. So the frictional force on the shoe will be to the left. So don't bombard the chat session, saying that the friction, how can the friction be to the left? No, we already know it is not on the wheel, it is on the shoe. On the shoe, it is to the left, okay, and it is trying to create counterclockwise movement, but the applied moment is clockwise. It is a non-self-energizing shoe brake. As it is non-self-energizing, the equation for torque is equal to mu times normal reaction. Normal reaction is PL by A mu B into radius. So here the torque is given as 100 Newton meter, 100 into 10 cube. Mu value is given as 1/4, so into P is given as EF into L value, you can notice this as 200 plus 225, it is 425 divided by A value from reaction to fulcrum, it is 200 plus, so mu value is 0.25, I am writing it as 1/4 into the value of B is 50 into Radius here is given as how much? So how much is the radius here? Let's see how much is the radius given. So without radius we cannot, okay, diameter is given as 400, the radius for this case is 200. Okay, let's see how smart I am now. Okay, so this is 1 sir, this is 2 sir, gone. Okay, and here you can notice that so this is 50 by 4. 50 by 4 is how much? 12.5. So this total value is 212.5. If that is 212.5, 212.5, 2s are how much? This is 1 sir, this is 2 sir. This 2 is 4, this 4 cancels out. The value of F comes out as 1000. You know, see, mostly people worry, you know, to solve the questions, but you can notice how simply we are solving these questions. You know, just by incorporating, you know, some simple procedures, we will be able to solve these questions, such complicated questions, even with ease. Okay, so try to understand the procedure here. I didn't take many steps to solve this. Just with simple techniques we were able to find the answer here in very minimal steps. Okay, I guess you got the answer here. I guess you got the answer. Good, Raj. Thank you so much, Raj Kumar. See, Shiva, you know, we are not going to take moments, you know, that's what. So you need to attend my session to understand this simple concept. Okay, so anyway, you know, if you have not attended, try to, if possible, try to attend that session to understand, or try to go through my notes if possible, so that you can understand this simple concept and you can get the answer in very limited steps. Okay. Now here, there is one more question. Let's not waste time. Okay. A force of 271 newtons is applied to a brake drum of 2 meter diameter. So here he says that, so the wrap angle is 180 degrees, which means pi radians here. So it is given as pi radians. The coefficient of friction between the drum and the band. See here how smart he is. He has given that as the coefficient of friction is given as 7 by 22. What is 22 by 7? It is pi. So here it is given as 1 divided by pi. The value of coefficient of friction is given as, so 1 divided by pi, direct one. Now here the braking torque applied in Newton meter is, as the rotation is counterclockwise, we can notice that on this side, on the top side we have pull, which means this is T1. Now as T1 is already known, we can write the equation for braking torque as T is equal to T1 into 1 minus 1 by e power mu theta into radius. Now we can notice that T1 is given as 271. So try to say the answer very fast. Let's see how many of you can do this. So mu into theta, mu is nothing but 1 by pi, theta is pi, mu theta value is 1 already. So here 1 minus 1 by e value is how much? 2.71 approx. So considering that to be 2.71, so this goes to the numerator here, 2.7 divided by 2.71. So this is 1 minus 1 by 2.71. So into R. In the numerator we have 1.71, in the denominator we have 2.71. This is ones are here hundreds, 100 into 1.71. Radius here it is already given as 1 meter here. As diameter is 2 meter, radius will be 1 meter. So we can answer here as 171 Newton meter. Very simple. See how fast, you know, we were able to solve these equations. Okay, you know, these are some standard cases. We are seeing some standard situations. So, you know, you also need to go through some such standard situations. Why? Because only such standard questions will be asked in this examination. Okay. Anyway, let's see this. So, in a ball bearing, if the number of balls is reduced to half, okay, and the diameter of the ball is increased to 4 times, okay, then the static load carrying capacity of the ball bearing is, we know that static load carrying capacity is written as K d square into Z by 5. Okay. Now here he says that the number of balls is reduced to half, okay, which means that becomes Z by 2. Okay. The diameter is, so what is happening to diameter? The diameter of ball is increased to 4 times. So here it is 4 times diameter whole square. So k divided by 5. Okay. Now what is k 4 square? 4 square is 16. Now here 2 1s are 2 8s are. This becomes 8 times the initial value. C2 becomes equal to 8 times C1. So it is increased or decreased. It is increased by 8 times. Okay. Moving ahead. Life of ball bearing at a load. See here, the load is given as 10 kilonewtons, and here the life is given as 24,000 hours. If the load is increased to, we know the relation here, L10 is equal to C by P whole power K. Now here did he say that as ball bearing, the value of K for ball bearing is 3. Now here he says that life and load relation is what? That is inverse. If load increases, life has to decrease. If load is doubled, what will happen to life? Life will decrease by 8 times. So 2 to the power 3 is what? 8. So obviously the life has to decrease by 8 times. 24,000 divided by 8. 8 3s are 24. This comes out as 3,000. So the answer here is what? B. So be as fast as you can to solve such simple questions. Don't waste your time. Okay. So fatafat, solve the question, move to the next one, and then try to save time and try to be able to solve as many questions in the examination. Okay. So majority of the students fail to complete, okay, fail to solve or fail to attempt all the questions in examination. Okay. So to avoid that, okay, you need to do such calculations very faster. Okay. Again the same question. So the answer here is B. Okay. So it was the previous one. Okay. Right. The purpose of providing. Okay. So this was from rolling contact bearings. Now here let's see from sliding contact bearings. Okay. This is also okay a kind of sliding contact bearing. We know that there are two different types here. So pivot or footstep bearing as well as collar bearing. Here, so collar is placed. So to the shaft we can have a collar. Okay. So generally if the load which is acting on the shaft is very large, in such situation we require large, very big collar to dissipate the load or to transfer the load to the support. If at all, if the space which is available is very small, in such situation we go with multiple collars. Okay. As we are going with multiple collars, what will happen? The same shaft. Okay. Observe, this is the shaft. Okay. Here in this case we go with, so this is actually one collar. If the load is more, we go with one more, we add one more collar. If the load is even more, we add one more collar. Okay. So depending on the load which is acting on the shaft, we can increase the number of collars. If at all, if the space which is available is small, I can increase the number of collars. As we have seen the similar case in case of clutches, multi-plate clutches, yes, we can also increase the number of collars here. Okay. Now here, what is the answer from the options? Increase frictional resistance to establish self-sustaining bearing condition, distribute the frictional load? No. So distribute the axial load because of limiting bearing pressure on the collar. So the answer here has to be D. Okay. Now, let's see. So few more questions and then let's close the session. The frictional torque transmitted in a conical pivot bearing. So generally a pivot bearing will be like this. So it is inclined. This is how a conical bearing will look like. Now in this situation what happens? So the load is acting in axial direction. As the load is acting in axial direction, here it is similar to cone clutch. Can you notice? It is very similar to cone clutch. Axial load, cone clutch. Now here, what is he asking? The frictional torque or the loss of friction due to the rotation here. The frictional torque here is what? T is equal to, generally, here we are considering the theory to be uniform pressure theory. Now we know that this is nothing but mu times normal reaction into radius, NP into RP. So here in case of conical shape, cone clutch, okay, the axial load and normal reaction relation is what? So mu is equal to N and W, relation is W divided by sin alpha, okay, into, as this is pivot bearing here, it is nothing but radius here is nothing but 2 by 3 times R. If you do this, so simple one, Now what is the answer here? 2 by 3 times mu times, so W into R into cosec alpha. The answer is D. Okay, very simple one. Starting friction is low in which type of lubrication? Starting friction is low. So we know that there are two different types of bearings. Okay, so one is hydrostatic and the one is hydrodynamic. So generally in case of hydrostatic lubrication, so the starting friction is low. Okay, now moving ahead. Okay, so here let's see this question from threaded fasteners. Which of the following stays are associated with the nut? So in case of whenever we are considering stud, okay, so generally because of the tightening, yes, we are getting tensile stresses. Okay, so we have seen that the thread can fail in shear. Okay, the thread which is present in case of the bolt, so that will try to come out as it is. Now it is subjected to transverse shear. You know, bending is an optional case. Okay, it is not necessary to, necessary that bending has to act. Only when there is misalignment in the shaft, there is possibility of bending. But considering, as no information is given, so this is, we can rule this out. We can rule this out, and we can see from the options. Okay, if at all, if 2 is also included in the options, then we can pick option 2. So let's see that. Okay, 3 is the answer. Torsional shears is also there. Why? Because the threads will be sliding one above the other. Obviously, there will be torsional shear also. Now here, what is the answer? The stud is subjected to, see, 1, 3, 4 are for sure, and 2 is optional. If 1, 2, 3, 4, all these options are given, then we will be picking that one. But the right answer has to be 1, 3 and 4. Okay, so 1, 3, 4. The answer here is B. If at all, if 1, 2, 3, 4 is also given, so in place of in D, if it is given as 1, 2, 3, 4, I'll pick option D. As it is not given, I'm choosing the answer as B here. That's it. Okay. Now, the function of washer. As washer we are using, so washer generally distributes the area. Okay. As it is distributing the area here, what is happening here? So the bearing area or the distribution area is increasing to provide more bearing area. Okay. The same. Okay. If you see turnbuckle will have right-handed and left-handed threads. Both are present in case of turnbuckle. Okay. To ensure self-locking of screw jack, it is essential that helix angle is, if you observe carefully, generally, for self-locking, any case of self-locking, so friction component has to be greater. In this case, friction component has to be greater than the helix angle. Okay. So which means helix, so here he is asking that helix angle is smaller, than obviously alpha should be lesser than friction angle. Only in such situation we can have self-locking of screw jack. Okay. So let's see this. Okay. So here rivets are made of, we know that rivet is generally made of ductile material. Okay. The answer here is B. Okay. The ratio of diameter of rivet hole to the pitch of rivets is, diameter of rivet hole to pitch is given as 0.25. He is asking us to identify the tearing efficiency of the joint. What is the tearing efficiency? It is 1 minus dh by p. So which means this value is 0.25. So eta t comes out as 75%. The answer here is what? B. Okay. I guess most of you are able to get these answers. Good, Rolex. Good. Keep it up. Okay. So this is again one of the most important which was asked. Okay. Let me solve the questions from this, and then let me, there are very few questions here. So we have almost come to an end. It is hardly 5 minutes. So we'll be closing the session. The rectangular steel plate is joined. Here you can notice that this is the plate which is joined with the help of 4 rivets here. Okay. So see how smart I am in solving this question. So this is the CG. Okay. If this is CG, the load is not passing through CG. As the load is not passing through CG, this is called as eccentric loading. Because of this eccentric loading, we are getting shear along with rotation, twisting rotation. Now because of eccentricity there is secondary load. So here primary load, so here the nearest rivet to the load here is these two. Okay, so and the farthest one from CG or both. Now I can say that these two rivets are generally prone to failure. Okay, if at all if failure has to happen, the nearest one to the load and the farthest one from CG has to undergo failure. Okay, now here as the load which is applied here is 840, on these rivets the primary load will be 210. Why? Because 840 divided by 4 is how much? 210. Okay, now here secondary load will be acting in tangential direction. How to identify secondary load? It is 840 into eccentricity is how much? 300 divided by, if you notice here carefully, from CG to this rivet, how much is the distance that we have? So here between the rivets the distance is 60, which means from center line to rivet this distance is 30, this distance is 30. Okay, if this distance is 30, as you can notice that from here to here also it is 30, this is a square arrangement. Now I can say that half of diagonal is, how much is half of diagonal? That is 30 root 2. Okay, now here there are 4 elements here into 30 root 2 whole square into 30 root 2. We can notice that 30 root 2 cancels out here. Now this is 1s are, this is 10s are, 4 1s are 210. Now here this comes out to be 210 into 10 by root 2. Okay, that's fine. So let me keep it as it is, which means the secondary load here is 210 into 10 by 2. Now here both are separated here by, as this is square arrangement, both are separated by 45 degrees. Now here primary is having 210, secondary is also having 210. Generally I'll take 210 common here. The resultant load which is acting here is 210 into under root. So here primary, what is left over if 210 is taken? 1 is present, 1 square plus 10 by root 2 whole square, okay, plus 2 into 1 into 10 by root 2 into 1 by root 2, cos 45 is 1 by root 2. Okay, here you can notice that root 2 into root 2 is 2 and 2 cancels out, this is 10 and here this is 1, and how much is this? So 10 square is 100, 100 divided by 2 is 50, 50 plus 60, 60 plus 1, so it is under root 61, okay, which is almost closer to 64, okay, which means this is, the under root value is almost closer to 8, which means I can say that this is 210 into, I am approximating into 8. So 8, 0, 8 ones are 8, so 16, 1680. The resultant has to be very much closer to 1680, but less than 1680. The answer here is C. Now you should be very smart enough in picking your answer. Okay, I guess this is very much clear. Okay, moving ahead. So very few questions are left over now. Okay, so let's conclude this session. So here you can notice, if at all, if from innermost row to the outermost row, if the number of rivets are increasing or decreasing, so in such situation, such arrangement is called as diamond riveting. In case of double strap, we know that, so we have already seen, in case of double strap, it is double shear. It is not single shear. Okay. In fillet weld, throat is, so is that the smallest distance or perpendicular distance from the root to the hypotenuse? Yes, to the face, it is the smallest distance between, or the perpendicular distance between the root to the hypotenuse, right? Okay, so try to find this answer. So we know that this is transverse weld. In case of transverse weld, so here pulling force is F. So here he is asking us to identify shear stress. So here sin 45 value is what? Sin 45 value is 1 by root 2. So 1 by root 2 in the sense 1 by 1.414, which means 0.707. Okay. So here if you notice, generally our value sin 45 as it is 0.707, it is there in the denominator. Yes, shear stress tau is nothing but equal to load divided by minimum throat area, which is T minimum into length. What is T minimum here? F divided by 0.707 times h into L. Here h is nothing but equal to the width of plate. So the answer here is B. Such very simple questions were asked. If two springs, okay, almost, let's see this question and then let's close this, almost over. Last one particular question from springs, okay, and then we are going to close this. For the spring system given in the figure, the equivalent stiffness is, you can notice that these two springs are in parallel. As these two are in parallel, the effective stiffness is 2K. Okay, but here you can notice that 2K plus 2K, that is added in series. So here that becomes what? Half of this value. What is half of 2K? That becomes K. The equivalent stiffness becomes equal to K for this case. Okay, such brilliant questions will be, such simple. See how many questions we have solved, almost closer to 50 questions we have solved in very short span of time. Okay, see why do I choose these many number of questions? So to say you that, okay, it is easy to solve these questions, easy to find the answer to the questions from machine design. That's the reason why I have taken this as a challenge to solve almost all 50 plus questions in this short span of time. So in that, yes, you have noticed even the numerical based questions are also present. Okay. So as you are preparing for ISRO, I wish you all the best for your examination. Take care. Bye-bye.